Change is constant. Advances that didn't seem possible are now within reach. In this lifetime, we may witness our biggest questions answered, our toughest challenges solved, our greatest advances reached. But this will require a different way to innovate, to nurture the far-fetched, to converge, to secure, to lead. The next frontiers will require seamless workflows, ultra-precision measurements, and intelligent analytics. They will require innovators to stay ahead, to go faster, to disrupt. And there's only one company in the world that can keep up. Keysight. With expertise in high-frequency design, scalable testing solutions, network visibility, complex modulation, protocols, and engaged with the latest standards and technology pioneers. We test so you can dream.
And now we are start. First representation of report will be Maksim Trubin from Novosibirsk State Technical University and online.
Dear conference participants, my name is Maksim, and the subject of my report is application of the least squares method to access the gain of a mathematical model of a stand for testing the strength of an aircraft structure. Strength testing is an important integral part of aircraft and spacecraft design. For strength tests, special stands are used, an example of which is shown on this slide. The photo clearly shows the structure of the loading system, which consists of a hydraulic servo drive, force sensor, mountings, and a load structure. The loading system reproduces the load externed on the structure during flight. The reproducible load is most often specified in the form of cyclograms of the sinusoidal load or static load. The aim of the work is to improve the accuracy of the implementation of a given cyclogram of the power loading of structure and eliminate high-frequency oscillations in the control loop of the stand electro-hydraulic servo drive. For testing, a stand with a load simulator is used. A model of the following type is used as a model of the stand. The choice of this model is based on experimental studies for the properties of this stand. A feature of the stand is the value of the gain of stand model G, with varies in a wide range, which leads to oscillation and reduce the accuracy of the tests being carried out. The solve of the discussed problem, a control system was proposed as a block diagram of which is shown on the slide. The system consists of a bench, control object, a regulation, and identification block to determine the gain G. As a control algorithm, a P control with an additional coefficient K with a bar is used, which is used to compensate for the changing value of the coefficient G, and is calculated as follows, where G0 is the nominal value of the coefficient G, and G with a tick is the value G calculated by identification unit in real time. The identification block used the least square method with a sliding window. The method used is based on minimizing the following functional. Since the values of the state variables are processed as samples, the derivative with respect to Y is replaced with an expression according to the finite difference method. Expressing the estimate G from this expression, you get the following expression. In order to verification of this method, the first thing was an experiment in which the compensation coefficient k with a bar is equal to 1, which corresponds to the usual operation of the stand with a P controller. The oscillograms show that there are oscillations in control action. Also, these fluctuations are clearly visible on the oscillogram of the regulation error. In this picture on the left, you can see the estimate of the G coefficient, where you can see that at the moment of fluctuation, the coefficient change in the range from 500 to 10,000. In second experiment, G coefficient compensation was included. A limitation was also introduced for estimating the coefficient G in order to avoid a gap in feedback. It can be seen then that the oscillation have disappeared, but the control error for the same values of the control parameters has increased. To reduce the control error, large coefficient of the P controller were taken previously. This was unvariable since it led the system instability. The regression error was reduced to half the value relative to the nominal operation of the stand. The application of the method of last squares with a sliding window had a positive effect on the control process and made it possible to get rid of the resulting oscillation during operation. Also, the solution made it possible to take large coefficients for the P controller, which reduce the regulation error from 3.5% to 2%. In the future, it is planned to refine the model of the stand, since this model does not fully reflect its works. It is also planned to study other methods for identifying the coefficient G in order to access their effectiveness. Thank you for your attention.
Any question, please? Okay, may I start? Maksim, I didn't see the dynamic model of your system. Maksim, are you here? Do you hear me?
And
I saw only control signal with delay. And the dynamic model, what's the different equation? Second order or first order?
First order.
First order with delay.
Yes.
Okay, and I thought that you proposed step changing of the gain. Maybe more correct, continuous changing of the gain. The function of range gain you propose at 16 gain, single gain, and could you show page? Oh. May I see presentation? Так, могу я по-русски? Okay. Your gain was changed by step. Maybe more useful changing continuous from initial value to the final value.
Mm, I don't.
Okay, another question. Okay, thank you very much. Okay. Professor Evgeny Sipin.
Good day.
Good day.
You speak us about your work, and you use in your work standard PI regulation. And I have question about this. Please say what science novelty in your work?
Science novelty is to adaptive coefficient G. The reduce of this coefficient is my
Okay, you propose that adaptive structure of the PI control
yes.
for improving the stability.
But I think it's a standard engineering task, or not?
It's not a standard engineering task, but it's a non-linear system.
Thank you.
Other questions? Okay, thank you. And another report with title online report, a method for suppressing industrial noise during voice control of an industrial robot. Andrey Spirkin, Penza State University.
Good afternoon, colleagues. I am Andrey Spirkin, postgraduate student. The time of my work, a method for suppressing industrial noise during voice control of an industrial robot. Today is the voice control system it is a hot topic. The speech recognition system has found its application in the method of controlling various devices. In the voice dialing of numbers, in the input of information for this system with a limit vocabulary, as well as in this full-fledged digital of large text. This slide shows a function diagram of a voice control system consisting of a microphone, a processing unit, and a recognition unit speech in the form of sound waves is captured by a microphone which convert them into an analog speech. Then this signal is converted into digital from filtered, segmented in fragment is in with informative parameters are extracted for further analysis. This slide shows the block diagram of the system. The system consists of two parts, a transmitter and a receiver. The work carried out a circuit simulation of an active noise suppressing device. A computer model of the device is shown on this slide. The principle of active noise cancellation is based on the creation of an antiphase signal function generates simulated microphone. One of the microphones simulates the operator's voice. The second only simulated the ambient noise. This slide shows the simulation result. On the left of this slide, the phase of the original signal is the sum is the phase of the receiver signal. Therefore, the separation of the uninformative signal does not occur. The right side of the slide shows that the phase of the output signal is an antiphase with the input signal. Noise cancellation is provided. The papers present the result of modeling in the interior frequency range audible by a person from 20 Hz to 20 kHz. The proposed device provides active noise collection in the interior range. The system of apparatus for recognizing speech command is best implemented on a typical neural network. The choice of a suitable neural network structure directly depends on the speed of command execution and on the resource consumed. Analysis of narrow topologies showed that the recurrent neural network and mere specifically recurrent by direction alone showed the memory neural network will work better. The structure of the neural network is shown on the slide. To train the base database, we use Google Speech Command Data Bus. An experiment study on the recognition of a speech command was carried out using the MATLAB software package with the help of the audio library add-on. A noisy signal was recognized with the command word "выключить" off. The signal mask is shown on this slide. After that, the neural network was trained. With the analysis of the obtained learning result shown that the keyword recognition accuracy is 91%. Also on this slide, on the right is the result of keyword recognition shown in red graph. This slide shows the appearance of the voice control module. Choose in the contour of the work was shown that voice control makes impossible to simplify the control of an industrial robot. Moreover, in condition of insufficient illumination and the apparatus hand are busy, speech is the only enable means of communication with the equipment. They developed electronic voice control unit for in industrial robot makes it possible to recognize the apparatus speech command in industrial noise condition. The proposed voice control unit can be used to control industrial robot. My report is over. Thank you for attention.
And now we will listen next reporter. Igor, please.
Hello, dear participants. The topic of my presentation is torque ripple reduction of permanent magnet synchronous motor using proportional integral resonant control with a delay of control response compensation. I want to start with a brief overview of controlled object. The permanent magnet synchronous motor is the alternating current motor, which inductor.
Sorry, please.
Yeah. Thanks. Which inductor consists of permanent magnets. This type of motor becomes extremely widespread in industry recently because of their advantages, such as operating condition with cos phi equal to 1, lack of dependence between the rotor speed and load, the increased value of efficiency in comparison with other type of alternating current drives, and so on. But also PMSM has a number. What's wrong? Mm-hmm. But PMSM has a number of disadvantages also. For example, the impossibility of direct start from zero initial conditions using rare earth materials for permanent magnets. But the most critical for high precision, low speed application is the presence of torque ripples. The resultant moment of PMSM consists of two components. First is a constant component, and the second is pulsating component, which leads to speed ripples, noise, and vibrations. Also, here is a speed PMSM waveform and its spectrum diagram, from which we can see the presence of described ripples. Also, on the spectrum diagram, we can see the harmonic frequencies, which influence mostly on the presence described pulsations. The pulsation components can be also divided into two groups. First is caused by non-sinusoidal flux density distribution around the air gap, and calling flux harmonics. Pulsation from this source can reach up 2 to 5% from nominal value. The second source is Cogent torque, and it appears because of interaction between rotor permanent magnets and the stator teeth. Pulsation from this source can reach up to 4% from nominal value. Also, pulsations can be caused by dead time of frequency converter and the error of stator currents and rotor speed measurements. The ways of torque ripple minimization can be also divided into two main groups. First is based on phased optimization of PMSM construction, with, for example, the correct choice of the weight of the magnetic poles and the technology of mounting the wing in the grooves. But this group of methods didn't find widespread use in industry because of increased in PMSM cost and decreasing in nominal speed. The second group is control methods, which basically consist of organization special control algorithm, which aimed on torque ripple suppression, for example, with a fast response 3-loop control system with different control structures. Using iterative lookup tables, neural network controls, physiologic controls, etc. To perform control system of any object, the mathematical model of it should be received. So here is a dynamic model of PMSM and DQ rotor reference frame, and the first equation represents the electricity equilibrium equation, which can be rewritten in form 2. Also, the vector columns of rotor flux density and stator voltage and current and the inductance matrix are presented here. The electromagnetic torque equation represents in equation 3 and should be taken into account that during research the non-silent PMSM was described, so the equation can be rewritten in a very simple equation with the multiplication between number of pole pairs, rotor flux density, and stator current in q-axis. The first derivative of speed can be written as presented in equation 4. Let's come to the mathematical description of pulsation. As was mentioned before, in the ideal motor operating conditions, the flux density distribution around the air gap has a sinusoidal form as presented in equation 5. However, due to manufacturing restrictions, there is some harmonic components, what present in equation 6. The Cogent torque is defined as the partial derivative of the motor magnetic energy to the rotor position, and presents in equation 7. Also, from equation 7, we can see that the Cogent torque is independent from stator current value. The conventional PI controller guarantees the elimination of steady-state error only for DC signals, but as was mentioned before, torque consists of some harmonic components. That's why we use equation 8 to perform a transfer function of resonant term, which represent in equation 9. This device allows infinite gain on the particular frequency omega 0 without phase shift and gaining on other frequencies. Considering the multiply harmonic nature and combine the resonant term with conventional PI controller, we can reach the transfer function of proportional-integral-resonant controller presented in equation 10. Such system, as usual, implemented on practice in a digital way with the different DSP and microprocessors. So the sampling procedure, the drawbacks of sampling procedure should be taken into account too. The well-known practical approach of this is use the resonant term with improved stability, except classical resonant term represent in equation 9. So the proportional integral resonant control with improved stability represent in equation 11. But this structure has one drawback. It's changing in frequency properties of the system. Here's the frequency response of resonant term of a classical resonant term, which represent as R1, and the resonant term with improved stability, which represent as R2. As we can see, there is a change in frequency properties, as we mentioned before. To eliminate these drawbacks, such a structure of control device will implement in control of rotor speed, where omega p is a transfer function of Liner-Smith predictor. Here is a block diagrams of control system with the Liner-Smith predictor and the Liner-Smith predictor block diagram itself. Here's a classical 3-loop control system of PMSM with inner current loop and speed loop and outer position loop. Also, it should be mentioned that only the inner rotor speed loop has been modified with the presented control device. Let's come to the modeling results. Here is the speed waveform with upper plot represent the controller with Liner-Smith predictor, and the bottom plot represent the control system without Liner-Smith predictor. As we can see, using Liner-Smith predictor in rotor speed control loop allow us to significantly eliminate ripples. Here is a frequency response of rotor speed controller with Liner-Smith predictor represents with digit 2, and without it represents in digit 1. As we can see, there are changes in frequency properties are absent, except small decreasing of the gain at resonant frequency. The proposed technique can significantly increase accuracy of position tracking in high-precision systems. This achieved due to the introduction of several resonant components into the structure of the controller with tuned to a given frequency. In addition, in order to compensate time delay caused by sampling procedure, the Liner-Smith predictor also included into speed control loop. Thank you for attention. If you have any questions, I'm glad to answer them.
Thank you. Your question? I have a, oh, okay.
Thank you for your speech. You say about some methods of solving this problem, but you choose only one method. Are you compare this method between?
During my master thesis, I prepare a literature review where I make a review of different control algorithms and describe their some of drawbacks of the other methods. For example, if we have, let me take it back. For example, in control method, there are a lookup table method, and this method has some drawbacks. Includes adjusting the control system with the changing of PMSM type or PMSM operation conditions. But this algorithm allows us to eliminate pulsations really simple, just modifying rotor speed control loop without any changing in position loop and current loop.
It's very nice. Thank you.
Other questions? Okay,
I have one question, if you allow me. Could you show? Yes, I have a question. Concerned with the slide number 8. In particular, if you take a look on expression 10, you have parameters of the resonance temp. The gain is K sub L, and the gain for integral part the same symbol, K sub L. Could you show slide 8? It will be more easy to see.
Wait a minute. Because here the resonant gain also adjusts as a double integral gain, as described on that slide. That's why I use the same description as the integral gain.
So K sub I the same gain in the integral part and in resonance part.
Yes.
Yes.
The resonant gain is a doubled integral gain.
Yeah, I see.
That's all.
What is the method for selection of the parameters, proportional and integral gain?
The adjustment of closed control loop to a desirable form.
I see. And last question, please. What is the value of the key? What is the number of the resonance term? How many resonance terms?
I implement only one resonant term, but also we have carried out an experiment where we use 3 resonant terms. During modeling, I use only one.
As in the slide number 3, you show that the range of ripple, spectrum of the ripple, belong to the interval from 1 up to 10 Hertz. And so you should use the multiply so some set of resonance term. Do you understand?
Not really.
Not really.
Which slide?
Number 3.
Sure. Okay, clear. So these plots are the result of preliminary experiment from previous researches. This research carried out on real PMSM, and during this research we use 3 resonant terms. These plots just given here to show the presented drawback. During modeling, this drawback can be modified just with external frequency distribution. So there are no ripples in just mathematical model in MATLAB. So I show these plots to show drawback more clearly. It's from another research on real PMSM.
Thank you. Yes.
And I can explain why the gain of integral and resonant components are equal. Because the frequency response of integral part of controller and resonant part of controller are the same. Frequency response. Valery Dmitrich.
Yes, thank you. I see. Thank you very much.
Other questions? Okay, thank you, Igor. Stanislav Ponomarev, Novosibirsk State Technical University, development and operation of software for controlling the components of a digital Recloser.
First of all, I want to thank IEEE organization team for allowing me to present my work at this great event. Let me briefly introduce myself. My name is Stanislav Ponomarev, and I am a first-year master's student of radio faculty of engineering and electronics from Novosibirsk State Technical University. And also I am working in Novosibirsk company Radio and Microelectronics that work is connected to. Thank you. So my today's work is development and operation of software for controlling the component of the digital recloser. So maybe okay. So let's move on to today's agenda. I divided my presentation into 3 major parts. In the beginning, I'll tell you the idea of the recloser and why we should make it digital. Next, I'll tell you about how to control data flow between internal components of the recloser with the software that I developed for the elements and of the recloser that I worked with. And in the end, I'll tell you about solution for the serious problem of the relay protection service we've developed PC program. And everyone and everything that I will tell you about, I'll follow with examples based on the experience in implementing the system in real operation. So let's start. What is recloser? Recloser is a sectionalizing point. So why we need sectionalizing point in our lines? I'll tell you about the overhead power transmission lines, and its general wear and tear is the cause of a lot of emergency situations. So we need such devices as sectionalizing point to make sure that if one section of the network will be broken or there will be some accidents, the other elements of the system, other sections of the network will be working well. So the main functions of the recloser is the sectioning and automation shutdown of the system and performing emergency reclosing with false short time faults. There is 2 types of sectionalizing points that could be installed on the ground or in the air on concrete supports. So recloser is an example of the concrete support type, and the second one is called metal-clad switchgear. This device is installed on the ground, but reclosers are better because their benefits in dimensions, in size, in cost, and in their easier to install features is very good for the companies that are working in networks. So this is a perspective and good choice. So why we should make it digital? There are a few features that digital recloser are had. So what is a digital recloser? It's a recloser within which all data is transmitted digitally. So there is only one analog discrete conversion in the beginning on combined current and voltage sensors. And then, what's going on? Okay. And then the data is transmitted in digital way by fiber optics to the control cubicle of the recloser. So there are many benefits of this approach because it increases observability of the electrical network, because we know a lot of components of the recloser. We reduce the overall dimensions of the device because we use digital components, no big analog things and elements inside this cubicle. We also improve performance and noise immunity of the data transmission because we just send in ones and zeros without any analog component, and we use modern transmission things. And next, we add commercial electricity metering because we're using the modern combined current and voltage sensors that allow us to do this. Now let's move on to internal structure of the digital recloser. There is a diagram that's representing it, and there is a working principle that I will tell you about. So first of all, it's about combined current and voltage sensors that measure the parameters of electrical network. These measurements goes on to data collection and transmission device and to relay protection unit. So there is an analysis of the measurements taken to identify abnormal situation, to control the network, and to control the vacuum circuit breaker to turn off or turn on the system or power line of the network. And next is transmission of measurements and data on the state of the recloser to the upper state equipment, to the SCADA systems or to the commercial metering systems. Let's talk about the first device that I work with is a digital device, is a data collection and transmission device, or DCTD. So this device taking measurements of from the sensors and synchronize them via GPS and 1 pulse per second technology, and forming it into special packets to further transmit to relay protection and automation unit and so on. So beside that, a lot of the SCADA systems and commercial metering systems use different data protocols. So we add additional module for analyzing this data. It's shown on the right side of the slide in upper level. So this additional module is analyzing data packets that comes from the router, because this DCTD can receive and transmit information. And when it's receiving information, this module is analyzing them and taking it into account and transmit data in a state that motherboard of the DCTD wants to have. So this is like a gateway for all the data from the upper systems. And next function of this module is a function of remote updating. So you can update your software of the motherboard of this component with this additional module. So it's so useful for operational systems. Let's move on. So the device that I talked about is connected to the router. And this router worked with the OpenVRT operation systems with Linux kernel. So it was programmed the way that it solves two main tasks. The first one is connection with the upper level systems that talk about the SCADA system. For example, in this slide, it's the Iris SCADA with the 104 protocol. And the second task is download oscillograms from a relay protection unit. It is so important for relay protection service, and I will tell you about in the next slide. But the software in this router is made to switch between the sending measurements from a relay protection unit and to downloading oscillograms from them. So if relay protection service want to download them, the router switches the function of the one RS485 port to make another function. And let's talk about this software. This is how it looks like, and here's the example. Maybe some accident is presented on a slide. So the tree falls on a line, and it's such an accident. So relay protection service saw that this recloser is switching off. So there is no electricity for consumers. But before they leave to the place, they want to see the oscillograms of this accident. So they open this program to download and analyze these oscillograms. So developed program can remotely connect to Recloser and download oscillograms from them. So this program uses SSH connection to Recloser via 3G network. In most cases, this 3G network is closed, so there is no possibilities for some kind of hacking the system, but this secure connection is taken to download the oscillograms. And then when this software download them, it saves it in standard ComTrade format that can be opened in any of the software for this kind of systems, for oscillograms. So this system was created, and then it was installed in the Marusina Novosibirsk region. On this slide you can see one of the Recloser installed in this area. The Recloser itself, it's installed in a central concrete support. The right and the left concrete support is the additional modules that could not be installed. And the advantages and benefits of using this Recloser could be divided into two parts. In the first part, it's technical advantages. It's, of course, the commercial metering. Of course, the maximum amount of information about the Recloser elements, because we use digital technologies and we could receive data about all states of the system and send it to the SCADA systems. And improvement of the power supply quality, because we install Recloser and we saving other section of the power line from the turning off. And economy effects could be described next. Reduction of cost for the operation of personnel, because the Recloser is really autonomous system. You shouldn't go to them and check it if it works okay, because everything is sent in wirelessly and you had all information about the working of the system. Next is exclusion of the possibility of unpaid energy, because we add in commercial metering systems, so there is no problem with that. And there is a low cost of delivery set in comparison to the other products, because this digital technologies is not so costing so much, and it's so easy for network operation to install them and to use them. On this slide you can look closer to the control cubicle. On the left side is the outside view of it, and on the right side you can see the rotor that I talked about. On the left side, the black color, the DCTD on the right side, and also I didn't mention that this system has batteries, so it can work without the power from the transmission lines, and also it has a control system for temperature and humidity inside it. So this is a scheme of the system in Marusina Novosibirsk region. There is 8 Reclosers that works well, and at the end of the development and testing stage in laboratory conditions, the system of 8 Reclosers went to a real operation in a real 10 kilovolts distribution network. So this system works well. Software that I created works without faults, but there were some problems with 3G connections and settings of the router and some wishes from the relay protection service on the program to download the oscillograms. But I do it now, and this system works all right. So it could be installed in any place. So after I wrote the article, these Reclosers was installed in other regions, not only in Novosibirsk. It was in city Anapa, in the south of Russia, and in Belarus, near the Minsk. So this system works, it works okay, and that's all that I want to tell you about. If there is any questions, please ask me. I would like to answer.
Okay, very interesting practical results.
Yes, thank you.
International application. Okay.
Some questions.
Okay.
The first, what is the purpose for taking oscillograms? If the tree falls on the wires, it's not necessary. What more information you will get?
Thank you for your question. If the tree falls on the line, there is a possibility that the tree is fired and go down without broken the line. So it could be.
And what about oscillograms?
So it will be an oscillogram that shows that it was easy to repair and there is no need to go to this place. You can turn it on and continue to operate this system.
Oscillograms will never help you to in this situation.
It could help to understand the type of situation. We could see that the tree is fall on the slide in this picture,
okay.
but
you should go and take this tree from these wires. Only this, but oscillogram is not.
Oscillograms will tell you about.
I don't understand why you need oscillogram where the tree is fall on the wires.
Oscillograms are needed for relay protection service in every situation. They love oscillograms.
Find the reasons.
They find the properties of the accident. They find the elements of this problem. Maybe they should go to this place in either way. But this is very useful for them. They want this feature, and there is a real problem for downloading the oscillograms when they go to the place. In every accident, they download it from the relay protection unit. But if they could download it remotely before leaving, they could make an adjustment and think about this in the new way.
And this next question, digital managements are not a novel in power engineering. And 20, 30 years ago, digital transformers with digital substations are used all over the world. What is novelty of your researches?
You will be surprised but there is like no things that's close to this one in our Russia's market, because there is sanctions. Yes, also the other companies like ABB or Siemens, they making the way to creating the digital.
All of this.
Not all. They not just like the gods of the power management, but
digital measurements.
In this approach, in the Recloser approach, this is a new approach to solve the problems of the Recloser. In the Russian market and worldwide, it's like on a modern way. It's not oldest technology. It's common technology, and in the sphere of power submitting and power transmitting, it's not so fastly goes into a lot of application.
I wish it how to you say. Thank you.
Thank you for your questions. Yes. Other question?
Another question. I would like to continue. Last question. I saw that you use a digital modem system and the data transmission to the relay system.
Oh,
very interesting.
Okay, it's a great question. The relay protection unit is called the relay just by the meaning of this, not just by the meaning of the word. This relay protection unit is also digital. This relay protection unit was made in Cheboksary by Chias company, and there is no real relays in there. There is a digital.
What does it mean, relay?
Just like analog relay system.
Digital management by
yes.
Relay is.
No. There is a digital communication lines with the switching.
10 kilovolts. Digital.
No. Relay. What are you talking about? Relay protection unit is using digital technologies and digital communication lines to control the switching equipment, like vacuum circuit breaker. Vacuum circuit breaker is analog.
Okay, power breaker.
Of course.
Okay.
But there is no real relay.
Relay is not breaker.
No. Relay is just a control system. It's called relay protection unit by the history. Yes.
Maybe online question. Okay, thank you.
The 11th Global Mobile Broadband Forum starts now.
Ready to discover how 5G innovations are creating new value for different industries? Then follow us.
The first week is about to start.
Let's see what the big guys from the industry are going to deliver.
越难的事情越值得做。我们需要的是大家携起手来，大胆思考，积极行动，开放合作。
The mobile ecosystem is the great enabler across whole economies as we look to the future. Our accelerated future. We are building it together with 5G.
未来是5G的10年，面向个人用户持续建设精品的5G 网络，面向行业客户发育5G 新能力，跟行业伙伴一起最大化网络价值，迎接5G 的黄金10年。
Besides the keynote, we also have several industry talks, including technical summits and roundtables.
Follow us and stay tuned to find out more about MBBF.
Next reporter Igor Starostin, Moscow State Technical University of Civil Aviation. The title of report is Identification of the DC discharge model of a lithium-ion battery using the potential streaming method and Scilab.
Значит, my name is Starostin Igor Evgenievich. Then this model of the lithium accumulators is building by analysis and modeling of physical and chemical process in these accumulators. For example, take the accumulators the series Sony US 18650 CTV and 6. Then modeling and analysis physical and chemical process using by model non-equilibrium thermodynamics and potential streaming method. Значит, а как слайды ли? Значит, the mathematical models of the physical and chemical process in the lithium accumulator is you see on this slide. Значит, this is the thing on this slide is reporting the Europe of the functional state of temperature in differential type. Значит, the modeling and physical and chemical process using by values of the coefficients is reporting of this slide. The set of dynamics of the discharge voltage and discharge temperature corresponding by these coefficients is reporting of this slide. On this set dynamics is building of the discharge model of voltage and temperature by using this URAV. This URAV is polynomials of third degree to the current capacity and second degree of the control dynamics. The discharge model of the temperature is polynomial of third degree of the current capacity and second degree of the control temperature. The error of building of this model of voltage and temperature from model of physical and chemical process is reporting of this slide. From this slide is see what error of the voltage model is not more 0,35%, and error of building of the temperature model is not more of the 1,4%. For experimental verifications of the model of напряжения using this experimental schema reporting of the slide and result of the reporting of the verification of this model reporting of this slide. The error of the voltage model is not more 10%. Thank you for attention. The condition, the method of the constructors a model of system characteristic by the physical and chemical process occurring in them was stated of the example of lithium accumulators. A mathematical model of the discharge of the direct current discharge mode is a lithium-ion battery was obtained, which can be used to solve practical problems, in particular balancing. Thank you for attention.
Thank you. Very interesting and good English.
First time in his life.
Okay. Questions, please. Igor, I know that the dynamic models of this process are famous, and what's new proposed in your model?
Значит, the new in my models is that this model that model is obtained from model on physical and chemical processes, and new in this model of physical and chemical processes that this model was being obtained potential streaming method, which is generated of the known models.
Okay.
Can we see slide 4?
Four slide.
Сначала я хочу увидеть, может я что-нибудь разлепил.
Так.
Page number 4. Okay. No.
I see on these pictures and on right pictures your graphics more than 100%. Please, I don't understand this. How which must.
What does it mean, 105%
Of capacity.
of the direct axis?
On left pictures an hour. More than 100%.
The discharge capacity is takes in unit relative the nominal capacity. The lithium-ion battery may be discharged on the nominal capacity more than nominal capacity. For example, is near overcharging.
Thank you.
Okay, before 100% accumulator generate energy, and after 100% consume. Yes, it was joke. Okay, thank you, Aleksey, Altukhov. Yeah.
I will present you the electrical flying wing design. It's a project Archangel, and this work was impossible without Sergey Petrovich Halutin, Vitaly Petrovich Kharkov, and Albert Aganezovich Vizov. It's Doctor of Technical Science and professors and its chiefs of Naukasoft, our industrial partner. I'm director of network analysis of ecosystem laboratory of Tambov State University. Also, I'm general general director and chief designer of this project of this company. It's Archangel ecosystem, and we are resident of science park of MGU and innovative cluster of Moscow. And now I think in some weeks we will become the resident of Skolkovo. And also I'm now in Moscow State University. I'm an employee of Innovation Economics Department. So the project background is the second slide. It's Professor Zhukovsky said that human will fly not by the strength of his muscles, but the strength of his mind. I fly more than a half of my life. I started with gliders, after in aerobatics in planes, helicopters, and I'm an instructor of skydiving. I'm a wing switcher, and doing the wing suite, wing suite skydiving, I had the idea to fly longer and longer, and to put the accumulators and the engines, the turbines, the electrical turbines, impellers. But I want that this instrument, the flight machine, could be used by everyone and everywhere, and it's necessary to do the vertical takeoff and landing. So the project Archangel is birth. And the second slide. We in economics and law, in our world, we use the platforms and ecosystems. And what is in technical is modality. Why it's so important? Because we can adapt the things for all the customers. And we, for example, some startups like startup Flytra develop flying trucks, flying cars, or aircraft. So with this architecture, we do our project Archangel, and the maximum weight is limited by the law, because when the aircraft is less than 150 kilograms, you don't need license of pilot, so everyone who could use it, and you don't need the registration. So the registration is additional costs and time. But with the same rules of flying, we could, after the registration, we could do not only the flying motorbike, but the flying car. So the second slide. And how we state the problem. There are three problems. The first is rational design. It's geometrical dimension, of course, aerodynamic layout. After this, the calculation of aerodynamic coefficients, so it's X, the Y, the drag and lift, and of course, this calculated, modelize the structural strengths. When you know this coefficient, we could design the electric power system with lithium-ion batteries. We use two types of lithium-ion batteries, one for starting and landing, and the other type, cobaltate, for the cruising. So we need to define the properties of electric power system and his operation modes, and of course including the possibility for recuperation. And the third, it's a synthesis of control law, how we can calculate the trajectory, and of course prevent all the emergency modes. The next slide, please. In basic provision, the wing structure is considered rigid. We don't fabricate ornithocopter. The bound XYZ, it's a normal coordinate system. The atmosphere is standard, and coordinate system is assumed to be in the second slide. Second slide, please. The kinematic equation could be written with Euler equation. So we refer to three angles. So the yaw, roll, and pitch. Second slide. The rotational motion dynamics is shown with this equation, with the inertia moment, wingspan, and gyroscopic moment. Then, and of course the thrust, because without the thrust we could not fly. The next slide. The translation equation is on this slide. So that it's flight path angle, and V it's ground speed. The next slide, please. And the most important in to sustain in the air, it's drag and lift coefficients. It's here. The next, and after this we could do yes. Thank you. The next, and we could calculate the centrifugal moments, who take by zero, and aerodynamic moments are determined by these equations. So the moments of roll, yaw, and pitch, due to the twin-gen thrust change. So the next slide, please. And in our program, we calculate, we could see here, the aircraft fly aerodynamic characteristic. And on the slide, on the right, it's polar with X and Y. So the for the lift and left thing, you could see the velocity field. So for the attack angle 16 degrees, and the speed in the maximum speed we assume will be for this profile will be 200 kilometers per hour, and this is cruise speed 150 kilometers. I don't say it before that with the limitation of the weight for 115 kilometers, the limitation by the law, we could we can put 70 kilograms of batteries. It's lithium-ion batteries from 18650 VTC, and with these accumulators with takeoff, vertical takeoff, we could voyage, we could fly more than 100 kilometers at the speed 200 kilometers, and we could lift 130 kilograms. So this is the man, or of course the woman, but the man with 100 kilograms, and the parachute, double parachute for landing or for the emergency operation. So the next slide, please. Here we could see the parameters, the lifting force and resistance at different speeds, at cruising speeds and maximum speed, or the aerodynamic quality. It's approximately 3. It's poor, like aerodynamic quality, but the wing structure, the wing profile without impellers and without pilot, it's the aerodynamic quality of this structure is 220. So impellers and human, it's decrease to 3 the aerodynamic quality. So the next slide, please. And this is a 3D model of MVP, minimal valuable prototype, who could lift off and land with the person. We use 32 impellers GP 120. It's from China, and with special drivers. At the difference between start and the cruising operation in energy is more than 5 times. So the using of the wing, so the start, it's like in a quadrocopter regime, and cruising, it's like in plane. So the difference of energy consumption and more than 5 times. So the next slide. And in flight control, if you mathematical model of controlling, it's written like this, where X is control object state vector, and U is impeller thrust. That's S, and we need to determine the control vector and the starting and final moments of control, and ensure the extremum of the cost function. As the next, please. We need to determine the solution of the linear differential equation. The next, please. And we write the function in matrix. So in matrix P, and in practical application, it should be written in Cauchy form, and the desired control is determined by the solving this equation. Please, the next slide. And for the one-dimensional control, we could write this formula like this, and in result, we obtain the formula on the end of this slide, and the synthesis of in the vertical takeoff mode, this is formula show the thrust difference between the bottom and top impellers. So we control the movement in one dimension with difference of from bottom and top impellers. And now in our prototype we add ailerons, so ailerons, differential ailerons, so ailerons, and the next mathematical problems will be how to coincide the difference of the thrust and the ailerons operation. The next, please. And on the result, we'll see how we need to vary the thrust. Yeah. So at the starting, the thrust is in the maximum, and in cruising after approximately 20 seconds of operation and 200 meters of the height, it's less than 500 newtons. So the next slide, please. We use all the invention of our century. So for the fabrication of prototype, we utilize 3D printer. It's a 3D printer CreateBot D600, and we print it with nylon, with nervous and longerons directly in the structure of the wing. So the first prototype, it's not with impellers, but with 4 propellers. So the start operation will be also like a quadrocopter, and at 100 meters will turn and fly like an plane. On this photo, we could see all our technical team with Sergey Petrovich Halutin, Albert Agonis Davidov, Vitaly Petrovich Kharkov, and our 2 modelers, 3D modelers and mathematical model, Konstantin and Daniel. The next slide, please. And for the future, so not for the future, we do some other flying projects. So on the left is the project Albatross. It's really simple for the skydivers and the special force requirements. The person, the parachute, the skydiver, take this Albatross. On the center, it's a box with accumulators, and it's 4 impellers. And with 5 kilograms of accumulators, we could fly more than 15 kilometers, starting from plane or helicopters or from the building. And on the right part of the slides is the project Altukhov. It's our Archangel, but who could dive and fly. So this project we do with collaboration of Ban State University, and the main difficulty here is engine, electrical engine, who could work also in under the water and in the sky. So the next slide. The next slide, please. The next slide.
Last page.
Last page. Okay. So yes, it's last page. So thank you very much for your attention, and I will pleasure to answer your question.
Okay, thank you. Please, your question. I have many questions. First of all, in the last picture, I see that electrical motor installed under the wings. Very interesting schemes.
Excuse me. It's about what project? Albatros or Altukhov?
How this
Albatros?
device,
Excuse me. Yes. So the Albatros it's on the left, and Altukhov it's on the right. It's with what, for the skydivers or for the water-air operation.
Right.
Could you repeat?
On the right, Altukhov.
What about the driver under the wing?
The motor installed under the wing.
The engine installed under. Yes, it's so we start like in quadrocopter mode. Here is the first design. What we prefer? So one engine. So not the one. It's 4 engine. It's for the air, and for engine. It's for the water regime.
Okay.
So
not flight for swimming.
Excuse me. Not for swimming. For the skydivers.
Underwater.
So underwater. And
okay.
Because the difference of the
application
between of the air and water, it's
okay. Next question. Could you explain the choice of elements of L matrix in the cost function between state vector x and transpose state vector in the cost function?
Mm-hmm. Back. Oh, okay. Okay.
L matrix.
Yeah.
How choose elements of L matrix?
The element of L matrix, it's you do the mathematical simulation with our colleague, and it's the numerical.
I see, but in my point of view, the meaning of physical meaning, control meaning of L matrix is the weight of different coordinates of state vector x.
Yes.
Am I right?
Yes. Yes.
Okay, and how choose? For example, the first coordinate is more important for this cost function. Another coordinates it's not important. How choose the elements?
We do a lot of mathematical simulation.
Okay, and
we do a lot of mathematical simulation for this. And now the first flying we do the first flying like in a quadrocopter regime will be in this Sunday. So here we all these graphs it's the simulations.
Okay, and you used for describing the motion Euler's angels.
Yeah.
But I know another approach for motion describing. For example, quaternion parameters.
Yes,
do you know?
Yes, I theoretically I know about quaternion. Yes.
Okay, that's all.
Yeah,
okay.
But our chief of mathematical modeling prefer Euler angles.
Because Euler angles doesn't describe all type of motion. I don't know how will be English. In Russian, эффект складывания рамок. Okay.
Yeah.
Other questions? Okay. Thank you, Aleksey.
Thank you very much.
Interesting. Next will be Artem Gorelyy. Of development of a hybrid method for planning the movement of a group of marine robotic complexes in a priori unknown environment with obstacles. Baltic State Technical University, St. Petersburg.
Hi, my name is Artem Gorelyy. The title was now told, and so okay. At first, I will tell you what our work is part of. So, marine robotics has grown from nascent navigation and control algorithms for underwater and surface vehicles to powered autonomous underwater vehicles routinely able to dive beyond 6,000 meters. We have seen underwater gliders cross the Atlantic Oceans and wave gliders across the Pacific. Marine robotics as a field is set up to make major contribution to understanding large-scale societal problems. Emerging marine robotic developments will afford scientists advanced tools to explore and exploit the oceans and at an unprecedented scale in a sustainable manner. Here you can see different projects of different countries, like Chinese Great Underwater Wall and other. It's all automation robotics without pilots. Okay. Here you can see resident subsea robotic systems look like you can see Shim and companies what make researching in this area. Resident subsea robotic systems combines all marine robotic technologies. This can be a complex of different marine and underwater vehicles. So, therefore, all unnamed vehicles must have a path planning system. In our case, the planner is a system of global and local planner. The global planner is the RT star method, rapidly exploring random tree in real time. The local planner is a potential field method, and it's used for forming group of vehicles. In potential field method, every vehicle from group attract to each other and goal point if it's necessary and repulse from obstacles. On right picture you can see scheme of potential field method, and on left scheme you can see how global and local planning work when no, you can read on scheme. So next slide. Here it's modeling of only potential field planner, and we can see on right side the local minimum problem when vehicle stand between obstacles in and attractive and repulsive force, assuming that the vehicle stand in one place and can move different way. That is a problem. And global planning system, it's RT star. We used its work like it's the sample-based method. This means that we build graph by random points. Every iteration of this algorithm, we take random point on area, then we're looking for the closest point for random and getting closer random point to closest point on epsilon distance. Then in R radius area from new point, all point become neighbors. Ага, я поближе просто могу стать. Хорошо. Так. So we have distances between new point and neighbors, and we have summary distance from finish to each neighbors. Sum of this called total cost. We choose the minimal total cost, so we have new age of our tree. Then we look in our radius area neighbors what can be child nodes when our new node can be parent node for them, and we rewire tree if this total cost of neighbors are cheaper than previous total cost. You can see rewiring procedures on right slide. What I tell 1 second ago, and on right side and down, you can see how this algorithm avoiding obstacles. When it see obstacle, it's make rewiring procedure and rebuilding path. So on next slide you can see our simulation, a simulation where group of vehicles what on potential field algorithms and it's moving with RT star algorithm and it's work together. So that is our work, what we do. So in future work we will try to make this algorithm in 3D, and we will make it in ROS framework to work with. So that's all.
Okay.
Thank you for attention.
Thank you.
Thank you for report. What is the difference between control of marine robots and aircraft robots?
I think in theory, not a lot of difference, but in water, even
more simple.
No, because in underwater there is water where is have a Streams, yes.
And in air,
yes,
there are streams.
It's two.
Yes.
Yes, it's more streams too.
The time is more longer than in air.
Okay. And what difference in air? It's simple to wired or to radio. Yes.
Connection.
Yes, connection. And underwater is hard to connect to device. It's radio waves. Not long distance for radio waves.
Your control system by operator, not autonomous.
Yeah, no, it's autonomous. All of autonomous.
And what the need of this connection to operator?
To task to send tasks.
I don't see differences. Only simplify.
Maybe.
May I help?
These methods work in air too because it's theoretical and path planning can be.
What's futures of marine environment regard to airspace?
What's future? What?
Water environment.
Yes.
When your object into the water, and when object inside the air.
Yes.
Airspace. What difference? What futures?
What difference?
For control.
For control, maybe only like in giant like motors, or maybe on environment, physical environment, like there is water, there is air, and that's all. I don't know any difference. For control.
Okay.
Is it the last?
Yes.
Yeah.
Yes.
You have a free time for questions.
Tell me, please, what are the properties of energy power source of this device, and what is the energy source?
Okay. Our company now make two projects. One big project, it's underwater glider. It's work like it's moving on sinusoidal trajectory, and it's moving by
like a fish.
No, not like a fish, like sinusoidal. Yes, and it's work like there is a battery pack on. Moving this move gain center, and it's going deeper. When it gains center moving, it's going deeper, and pump catch water, so it's increase their weight, and it's going down, and when it's
recuperation.
Recuperation, yes.
You want to take yourself from the marine.
Yes, and it's very cheap for energy. It's very cheap to catch water and move battery pack.
And what is the first energy? Input energy.
Battery.
You move. You need energy to move. And then you can get this energy for battery.
But
understand?
No. Start with power battery.
Yes.
Yes.
And the energy, the volume of this energy is limited.
Yes.
You have a power restriction in your object. Power limit.
Power limit. Now we calculating this time, but different countries' gliders can travel like half of year without battery.
Okay. And what about Russian designers of these devices? Bauman University Institute of Oceanology, I don't know what is
Ocean
in
research.
English. Ocean. You don't show these devices, but they take awards in competitions, and they are good.
Underwater glider, we are first company who made it in real world, working prototype first. No one in Russia made this.
But I see so
underwater gliders. Maybe we talk about different things because maybe because underwater gliders only
high speed. This is high speed.
No, it's very low speed.
Okay, there is Mir 1, maybe.
Mir?
Yes. Discovery of Titanic place.
Yes, and it's different. It's working on motors like propellers, impellers, but our haven't got impellers. It's haven't got motors. It's work by physical laws, like when you increasing your weight, you go deeper. When you decreasing your weight, you go up.
Archimedes law.
Yeah, Archimedes law. Yes. yes, Archimedes law.
Okay. That's all? It was last report?
Yes.
Okay. I beg your pardon again.
Thank you.
5G is coming for a super connected world. The car industry is one of the first verticals to take advantage of cutting-edge 5G solution for improving road safety. Huawei is spending significant efforts to bring 5G into the car industry. In June 2017, China Mobile, Saica Motor, and Huawei have jointly conducted the first field trial in China for teleoperated driving. The tests took place in Shanghai. Powered by 5G, ultra-high bandwidth, and ultra-low latency, a person sitting miles away from the car can remotely and easily drive the car as precisely as he would be in the driving seat. With 50 megs per second uplink throughput, the multi-HD video data coming from the car can be transmitted to the driver immediately, while the control signals from the remote driver can also be transmitted back to the car under 10 milliseconds. The driver seems sitting in the car to drive it like people do today. Applications for teleoperated driving could be applied to dangerous environments like mining and construction fields. There are other scenarios where teleoperated can play a major role, such as car rental and car sharing projects. In June 2017, Huawei has also conducted platooning trial in Germany and in China. With 5G ultra-low latency, the control signals can be transmitted from the pilot car to the following cars within 5 milliseconds. It allows the platooning fleet to manage all events, such as the close tracking, the lane change, and the emergency brake easily, thanks to the precise synchronization among all vehicles forming the platooning fleet. Such a scenario will improve the road safety, save labor cost, and lower the fuel consumption by shortening the distance between platooning vehicles. Recently, in Beijing and Shanghai field trials, Huawei has completed a series of 5G new radio tests. The downlink peak throughput has reached over 6 gigabytes per second for a single user. The cell peak rate has exceeded 18 gigabytes per second. Moreover, these field trials have demonstrated that the 5G NR air interface latency is well below 0.5 milliseconds, and the total cell capacity can support over 4 million single cell connections. Let's move forward to a more connected and intelligent world enabled by 5G.